The invisible whirlpool. How a hidden center governs the motion of a calm stream. Imagine a vast field of force that flows in perfect circles around a central vertical axis. This field is unique because as you move further away from the center, the strength of the flow weakens. If you were to place a tiny paddle wheel anywhere in the stream, it wouldn't spin, and if you watched the water, it wouldn't seem to be bunching up or thinning out anywhere. Locally, the field feels completely calm and curl-free. However, this local tranquility hides a surprising global secret that only reveals itself when you take a long journey. The journey around the void. The problem explores a specific 3D path that winds through this field. This path is not a simple circle. It wobbles up and down and changes its distance from the center as it travels. Despite this complexity, the score or circulation accumulated along the journey depends on only one thing: how many times you orbit the central axis. In the first two demonstrations, we track a traveler who completes exactly 2 full laps around the center. Because the force of the field is perfectly aligned with the circular direction, every bit of angular progress adds to the total circulation. By the time the traveler finishes their 2 loops, they have accumulated a total circulation value of 4 pi. The wobbling height and the changing distance from the center turn out to be irrelevant distractions. The only thing that matters is the total change in the angle. The power of topology. The third and fourth demonstrations reveal why the center of the field is so special. We compare 2 different travelers. The enclosing traveler. This person loops around the central axis twice. Because they trap the center inside their path, they capture the influence of a hidden singularity, a point where the field becomes infinitely strong and the usual rules of calmness break down. Their final score is 4 pi. The sidestep traveler. This person moves through the field in a loop but stays entirely to one side of the center. As they move forward, they accumulate a positive score, but as they curve back to close their loop, they move against the field's flow, perfectly canceling out their earlier gains. Their final circulation score is exactly 0. Why the center matters. This phenomenon is a classic example of how the shape and connectedness of a path, its topology, can change the outcome of a physical measurement. Even though